Hello everybody. So we'll be starting module number 3 today. So module number 3 has two parts. The first part is support reaction in beams and the second part is trusses. So we'll be starting the first part of third module now. We'll be starting the first part of third module, which is support reaction in beams. See, as you know, beam is a horizontal member. Beam is a horizontal structural component or structural member. Beam is a horizontal member which carries vertical loads. Beam is a horizontal member which carries vertical loads. Since beam is a horizontal member, it has to be supported by a number of supports. It can be either the extreme end supports or the intermediate supports. So since beam is a horizontal member, it has to be supported by a number of supports. It can be either end supports or the intermediate supports. So these are the two end supports in this particular example which I have considered. These are the two end supports, and this is the horizontal structure which is beam, which carries vertical loads. Now, whenever beam is in contact with the support, support offers a reaction on the beam. This concept is same as that of the previous concept which you went through in the previous module. Whenever a body is in contact with the surface would offer a reaction on the body, and that reaction is called as surface reaction or the normal reaction offered by the body. Similar to that, whenever a beam is in contact with the support, whenever beam is in contact with a particular support or n number of supports, all the supports will offer reaction on the beam, and that reaction is called as support reaction. Support reaction. So support reaction is a reaction offered by all the supports which are in contact with the beam, which are in contact with the particular beam. So whenever beam comes in contact with the support offers a reaction, and that reaction is called as support reaction. As simple as that. So in order to understand support reactions, you have to go through the types of supports. You have to go through all the types of supports available, all the types. So you have 4 types of supports. The first type is simple support. First type is simple support. Second type is roller support. Third type is hinged support. And the fourth type is fixed support. These are the 4 types of supports available. These are the 4 types of support available. So support reaction, or reaction offered by a particular support, the reaction depends on its type. Whether the given support is simple support or a roller support or a hinge support or a fixed support. It depends on its type. So some of the supports, for example, simple support offers only 1 support reaction, whereas hinge support offers only 2 reactions. Fixed support, in other case, it offers 3 reactions. It all depends on the type of support which is being used in a particular scenario. So we have to go through all of these types in order to understand the support reactions. First of all, the basic concept is basic concept of support reactions, that it's just the reaction offered by the support whenever beam is in contact with the support. Whenever beam comes in contact with the support offers a reaction, and that reaction is called as support reaction, and it depends on the type. It depends on the type of support which is being used in the scenario. It depends on the type. So you have 4 types basically. These are the basic 4 types: simple support, roller support, hinge support, and fixed support. So let us go through these types in order to understand the concept of support reaction in beams. Let us go through all the 4 types simultaneously, and let us try to understand the type of reaction offered by all of these supports. So let us consider all the supports simultaneously. Let the first support be simple support, and the second type be roller support, and third type be hinged support, and the fourth type be fixed support. These are the 4 types of supports available. These are the 4 types. So support reaction, or reaction offered by the support, depends on the type. So you find the support reaction depending on the type of support which is being given to you. So usually in the numericals or in the problem, support will be given in the form of a drawing. It will not be mentioned in the question. This particular support is being used will not be mentioned in the question. You'll be given with a drawing and you're supposed to understand or you're supposed to identify the support just by going through the drawing. Just by going through the drawing. Now let us go through simple support. Let us go through simple support. In simple support, let me consider a small beam cross section. Simple support is drawn in this way. Simple support is drawn in this way. Simple support is drawn in this way. This is how you draw simple support. So in simple support, beam is just placed on the support. Beam is just placed on the support without having any fixture or without fixing the beam to the support. It's been just placed on the support. There are no hinges which fixes the beam to the support. So simple support is a type where beam is just placed on the support in this way. If these two are the supports, beam is just placed without fixing it to the support. The beam is just being placed. If this is the beam, if these two are the supports, beam is just being placed on two of the supports, on these two supports. So this is the first type. In this case, if a beam is supported by simple support, simple support offers reaction only in vertical direction. If this point is A and if this point is B, so simple support offers reaction only in one direction, in Y direction only. Only one reaction it offers. You have two supports here. You have two supports and each support will offer only one reaction, that too in Y direction. So let me write this as RAY and let me write this as RBY. So if a beam is supported using simple support will offer reaction only in one direction, that is in vertical direction. Let me just show you an example of simple support. We just go through this. Here, these two are considered as supports, and this lintel or this beam is simply kept over these two supports. It's just being placed over these two supports. This is a small example for simple support. Even here, if you consider these two as the supports, the lintel or beam is just kept over these two supports. So in this case, this type is called as simple support. So in the case of simple support, the simple support offers reaction only in one direction, that is in Y direction. Now let us go through the second type of support, which is roller support. Let me consider another cross section. Roller support is always indicated in this way. It's been drawn in this way. Roller support is always drawn in this way. This is how you draw. Now indicate the roller support. So let me consider this point as A and this point as B. So roller support, even in the case of roller support, the reaction offered by roller support is only in one direction, and even the roller support offers only one direction, same as that of simple support. Only one reaction, that too in Y direction. RAY and RBY. So a roller support offers reaction only in one direction, that is in Y direction. So even simple support offers reaction only in one direction, that is in Y direction, and even the roller support offers reaction only in one direction, that is in Y direction. So both simple and roller supports offer reaction only in one direction. It offers only one reaction. Both simple and roller support. Both of these supports offer only one support reaction. Which is in the vertical direction or in Y direction. Okay. These are the first two types. Let us go to the third type, which is hinged support. So hinge support is drawn in this way. Before that, let me just show you an example for roller support. The real time example as you went through. The example for simple support. This is an example for roller support. You can see this is a steel girder or a steel beam which is supported using a roller support. Even here, these are the steel girders, steel beams. Even here, it is being supported using a roller support. roller support. And even here, a steel girder is being supported using a roller support. So these are the real time or real life application of roller support. This is how the roller support looks like. So in the case of simple support and roller support, reaction is only in one direction and only one reaction is offered by one simple or roller support. Only one reaction is being offered in y direction. In y direction. Y. Even here in simple support, reaction is offered only in one direction. In y direction. Let us concentrate on the third type now, which is hinged support. Which is hinged support. Let me consider a beam cross section in this way. A beam cross section. And hinge support is drawn in this way. Hinge support is drawn in this way. This is how you draw hinge support. This is how you draw hinge support. This is how you draw hinge support. Now, let me consider this as point A and this as point B. So if a particular beam is supported using hinge support will offer reaction in two directions, or it will offer two reactions. Whereas simple and roller supports offer only one reaction, which is in the upper direction, which is in y direction. Simple support offers only one reaction, roller support offers only one reaction, whereas hinged support offers two reactions. Hinge support offers two reactions. One of the reactions will be in y direction, RAY, and other reaction in x direction, RAX. Even here, this is the other support. One reaction in y direction, RBY, and the other reaction in x direction, RBX. Or basically, in one single hinge support, it offers two reactions. One in y direction, RY, and the other one in x direction, RX. So hope this is clear. In a hinge support, there are two reactions in mutually perpendicular directions. Mutually perpendicular. Both are mutually perpendicular. One is in x direction and one is in y direction. So again, simple support offers reaction in the y direction only, and it offers only one reaction. Roller support offers only one reaction, that too in y direction. Whereas hinged support offers two reactions, one in y direction, the other one in x direction. So these are the first three types. I'll just show you the example for hinge support as well. A small real-time example of hinge support. This is how support is being hinged here. So this is an example for hinged support. This is how it goes. And the last type, final type, is fixed support. Fixed support is always indicated in this way. If this is the beam, fixed support is indicated in this way. Two supports, A and B. Which are fixed. So if a particular beam, this is the beam cross section. AB is the beam cross section here. I've drawn it small. AB is the beam cross section available. And these are the two fixed supports. Fixed supports are drawn in this way, indicated in this way. So if a particular beam cross section is supported using fixed support will offer reaction in three directions, or three reactions are offered by fixed support. The first reaction is in y direction, RAY, and the second reaction is in x direction, RAX, and an external moment, A, and an external moment. Three reactions, RAY, RAX, and a moment. And let us draw the reaction for support B as well. Even this is fixed. RBY, y direction, RBX, and a moment MB, So let me show this here. One reaction in y direction, RY, other reaction in x direction, RX, along with a moment M. So you have three reactions. As far as fixed support is concerned, you have three reactions. So these are the four types. Of support system available. So if a beam is supported using simple support will offer only one reaction in y direction. If the same beam is supported using roller support, even roller support offers a reaction only in one direction and it offers only one reaction, that too in y direction. Now, if you consider hinge support, if a particular cross section is supported using hinge support offers two reactions. Hinge support offers two reactions, one in y direction and the other one in x direction. Whereas if a particular beam cross section is supported using fixed support, it will offer three reactions, one in y direction, other one in x direction, along with the moment. Even moment is considered as one of the support reactions. So these are the four types. You have to remember this. You have to clearly remember this. If a beam is supported, if simple support is used, one reaction in y direction. If roller support is used, one reaction in y direction. If hinge support is used, two reactions in x and y direction. If fixed support is used, three reactions, one in y direction, x direction, and a moment. So you have to remember this. Remember the number of reactions offered by all of these supports, and you should know how to identify the type of support. If simple support is given, it will be drawn in this way. If roller support is given, it will be drawn in this way. If hinge support is given, it will be drawn in this way. And if fixed support is given, it will be drawn in this way. This is how you indicate, and this you have to remember. This you have to remember. Simple support offers one reaction, roller support offers one reaction, hinge support offers two reactions, fixed support offers three reactions. So this you have to remember. Now, let us try to understand why a particular support offers only one reaction, why simple support offers only one reaction, why roller support offers only one reaction, why hinge support offers two reactions, and why fixed support offers three reactions. Let us try to understand. First of all, you have to remember this. First of all, you have to remember the number of reactions offered by all the types. First of all, you have to remember. Now, let us understand why simple support offers only one reaction, in that too in y direction, and why roller support offers only one reaction, why hinge support offers two reactions, and why fixed support offers three reactions. Now, here in a simple support, beam is just placed on the support. Beam is just placed on the support. Since beam is just placed on the support, beam can be moved anywhere horizontally. So if I consider these two as supports, and if this is the beam, here beam can be moved horizontally anywhere. It has freedom of movement in horizontal direction. It can move horizontally, and I can rotate the beam as well in z direction. I can rotate anyhow, is it not? Beam can move horizontally to the left or to the right, and the beam can be rotated. Beam can be rotated, but it cannot move vertically. There is no free vertical movement. So beam can move horizontally, beam can rotate, but the beam cannot move vertically, cannot move freely in vertical direction. So it has one restriction of motion. The restriction is in vertical direction. So beam has no free movement in vertical direction in simple support. Whereas in horizontal direction it has free movement. It can rotate as well in z direction. In x direction it can move freely. In z direction it can move freely. Rotation is free, but it cannot move freely in y direction. It cannot move freely in y direction. So there is one restriction which is in y direction. There is one restriction which is in y direction. That's why the reaction is only one in the same direction. Number of restrictions is equal to number of reactions. Number of restrictions is equal to number of reactions. Number of restrictions is equal to number of reactions. So here in simple support, there is only one restriction, that too for the vertical motion. So beam cannot freely move in y direction. That's why you have only one reaction which moves in y direction itself. Got it? So you have three types of restrictions. Restriction for motion along x direction, restriction for motion along y direction, restriction for motion along z direction, which is the rotation. So here in simple support, the beam can move freely along x axis. Beam can freely move along z axis. It can rotate, but the beam cannot freely move along y axis. There is one restriction in y direction. So there is one reaction in y direction itself. Number of restriction is equal to number of reactions. Now let us concentrate on roller support. Let us concentrate on roller support. Here, beam can move. If I consider this as these two as the roller supports, here beam can move along with the support. Support can move because support has rollers. Support has rollers, so beam can move horizontally anywhere along with the support. So horizontal motion is allowed again. It can move horizontally either to the left or right very freely because support has rollers. It has wheels. It can move. Support has rollers. And the beam, it is not being fixed again. Beam is not being fixed. It's just kept over the roller support, so it can rotate as well. So it can move in X direction. It can move in Z direction. So what's the restriction? Restriction is only in Y direction. Again, restriction is only in Y direction. Even in the case of roller support, if I consider these two as roller support, beam is kept on the roller support. Roller support has wheels, so it can move anywhere. So beam is just placed on the roller support, so beam can move horizontally with the help of support itself. So there is no restriction for horizontal motion. So beam can be rotated. The beam can be rotated anywhere. So there is no restriction in the Z direction as well. So restriction is in Y direction again. Restriction is only in Y direction, and hence you have only one reaction in Y direction. Number of restrictions is equal to number of reactions again. Number of restrictions is equal to number of reactions again. Now let us come to the third type, hinge support. Here support is hinged, or beam is hinged to the support. Beam is hinged to the support, as you can see here. So beam is hinged here. If you can see here, it's been hinged. Even here, beam is been hinged to the support. The beam is been hinged to the support. So since the beam is been hinged to the support, it cannot move horizontally. So there is a restriction for horizontal motion. It cannot move horizontally because it is been hinged. It's been hinged. Whereas in these two cases, beam is just placed on the support. Here, beam is hinged. So it has restriction for motion along X direction. That's why you have a reaction along X direction. It cannot move vertically as well. It has restriction in vertical direction. That's why you have another reaction in vertical direction. So there are restrictions in two directions, both in X and Y direction. It cannot move in X direction as well as it cannot move in Y direction. That's why you have two reactions, one in X direction, the other one in Y direction, the other one in Y direction. So it can be rotated with the help of hinge. Beam can be rotated with the help of hinge. Beam can be rotated anywhere. Beam can be rotated, but it cannot be moved horizontally or vertically. It cannot be moved horizontally or vertically, but it can be rotated because it is hinged. About the hinge, you can rotate the beam. About the hinge, you can rotate the beam. So rotation is allowed along Z axis. Rotation is allowed, but the movement along X axis and Y axis is being restricted. That's why you have two reactions, one in X direction and other one in Y direction. Here the restriction is only in Y direction. That's why you have only one reaction in Y direction. Here you have restriction in two directions. That's why you have two reactions, Rx and Ry. Now coming to the fixed support, the last support. So if a beam is fixed to the support, beam can neither move horizontally. If this is the fixed support, if this beam is fixed, it cannot move horizontally, it is fixed. So one restriction, horizontal direction. It cannot move vertically. So second restriction, vertical direction. It cannot even rotate because it is fixed. It cannot even rotate. And third restriction in Z axis. So you have three restrictions total. You have three restrictions in fixed support. So number of restrictions should be equal to number of reactions. So how many reactions do we have here? One in Y direction, first reaction, one in X direction, and the third reaction is the moment because the rotation is not allowed here. Since the rotation is not allowed, you have moment as one of the support reactions. Hope this is clear. So number of restrictions offered by that particular support is equal to number of reactions offered by the same support. So here in simple support, restriction is only in one direction. It can freely move in the other two directions. Even in roller support, the beam can freely move in the other two directions. It has restriction only in one direction, that is in Y direction. In hinge support, the beam has restriction in two directions. It cannot move horizontally, it cannot move vertically, it can rotate. So that's why you have two reactions because it has two restrictions. In a fixed support, you have three restrictions. That's why you have three reactions. One in y direction, one in x direction, and the other one is moment, which acts as one of the support reactions since it cannot rotate. So these are the four types. You have to remember this. You have to remember. If a beam is supported using simple support, it offers one reaction. If a beam is supported using roller support, it offers two reactions. If it is hinge support, it offers three reactions. And if it is fixed support, hinge to two reactions. If it is fixed, then it will be three reactions. This you have to remember. To solve all the problems, you should know this. Finally. If the support is roller support, you have two reactions. You have reaction only in one direction, vertical direction, only one direction. If it is pinned, this is hinged. You have two reactions, horizontal and vertical. If it is fixed, horizontal, vertical, and moment. If it is simple, it's just vertical. This is the resisting load or the resistance or the number of resistance what you have. The restriction. So hope this is clear. You have to remember this. You have to know this in order to solve the numericals. You should remember. So in the problem, the name of the support will not be given. You have to identify the type of support just by going through the diagram given. So we'll continue with the next concept in the next video. Thank you.